Welcome back to our channel. Today we're going to explore a fundamental concept in the world of programming: object-oriented programming, or OOP. This paradigm is widely used in many programming languages like Java, C++, and Python, and it's essential for creating scalable and maintainable code. In this video, we'll cover the 4 key principles of OOP: abstraction, encapsulation, inheritance, and polymorphism. We'll illustrate each principle with relatable examples, practical applications, and even some coding snippets to help you grasp these concepts thoroughly. So, let's dive right in. To kick things off, let's understand what OOP really is. At its core, object-oriented programming is about organizing software design around data, or objects, rather than functions and logic. Imagine this scenario. You're tasked with developing a school management system. Without OOP, you would write a long, complicated set of instructions, a monolithic codebase, where student information, teacher data, and class schedules are all jumbled together. This approach can lead to a complicated mess of code, making it challenging to maintain and expand. However, when you adopt OOP, you can break down the system into discrete parts called objects. Think of a student object, a teacher object, and a course object. Each of these objects has its own attributes, data, and methods, functions, allowing for a much cleaner and organized structure. This modular approach not only simplifies development, but also makes it easier to troubleshoot and scale your application in the future. Now let's explore the first principle of OOP: abstraction. Abstraction is about hiding complex implementation details and showing only the essential features of an object. This allows users to interact with the object without needing to understand all its intricacies. Consider an ATM machine. When you walk up to an ATM, you insert your card, enter your PIN, and select an option to withdraw cash. You don't need to know how the ATM communicates with the bank's servers, how it validates your PIN, or how it dispenses cash. You simply interact with the buttons and screens designed for your convenience. This is abstraction in action. Let's take the example of a car. When you drive, you only need to be aware of the steering wheel, pedals, and gear shift. You don't need to know how the engine, transmission, or braking systems work internally. The manufacturer has abstracted these details away, allowing you to operate the vehicle without confusion. In our school management system, we can implement abstraction by creating an abstract class called person. This class can include common properties such as name, age, and contact info, while subclasses like student and teacher will focus on their unique features. By doing this, we streamline our code and focus only on what's necessary for each object. Next up is encapsulation. This principle ensures that an object's internal state is protected and can only be modified through specific methods. By encapsulating data, we prevent accidental interference and misuse. Let's consider a smartphone app. When you interact with the app, you're using its interface without needing to know how it manages data or communicates with servers. For instance, when you send a text message, you tap Send without worrying about the underlying processes that handle your message. In online banking, your account details, like balance and transaction history, are encapsulated. You can view your balance through a method like getBalance, but you cannot change it directly. This protects sensitive information and prevents unauthorized access or accidental changes. In our school management system, we might have a student class that encapsulates personal details such as grades and attendance. We can create methods like addGrade and getAttendance that allow controlled access to these private properties, ensuring data integrity. The third principle is inheritance. Inheritance allows one class to inherit the properties and behaviors of another, promoting code reusability and establishing relationships between classes. Think of your family tree. You inherit traits from your parents, things like eye color, hair texture, and even certain personality traits. Similarly, in programming, inheritance lets us create a base class and derive new classes from it. Let's delve into an example involving animals. We can have a base class called animal with general properties like species, age, and methods such as eat and sleep. From this class, we can create subclasses like dog and cat. The dog class would inherit properties and methods from animal, but it could also introduce its unique attributes, such as breed and a method called bark. In our school management system, we can create a person class with basic attributes like name, age, and contact info. Then we can derive subclasses like student and teacher. Both subclasses inherit the properties from person, allowing us to reuse common features while also implementing their specific properties and behaviors. The third principle is inheritance. Inheritance allows one class to inherit the properties and behaviors of another, promoting code reusability and establishing relationships between classes. Think of your family tree. You inherit traits from your parents, things like eye color, hair texture, and even certain personality traits. Similarly, in programming, inheritance lets us create a base class and derive new classes from it. Let's delve into an example involving animals. We can have a base class called animal with general properties like species, age, and methods such as eat and sleep. From this class, we can create subclasses like dog and cat. The dog class would inherit properties and methods from animal, but it could also introduce its unique attributes, such as breed and a method called bark. In our school management system, we can create a person class with basic attributes like name, age, and contact info. Then we can derive subclasses like student and teacher. Both subclasses inherit the properties from person, allowing us to reuse common features while also implementing their specific properties and behaviors. Now let's talk about polymorphism. This principle allows methods to do different things based on the object they're called on, even though they share the same name. Think about various media players. When you call the play function, it behaves differently depending on whether you're playing a song, a podcast, or an audiobook. Each media type has its own implementation of how to play, but they all respond to the same command. Consider an online shopping platform. You have multiple payment methods like credit card, PayPal, and Bitcoin. Each of these can implement a process payment method that functions differently based on the payment type being used. In our school management system, we might have a method called GenerateReport in the person class. When invoked on a student object, it could generate a report card, while invoking it on a teacher object might create a performance evaluation. This flexibility is the essence of polymorphism, allowing similar functions to be executed in different ways based on the object type. Let's now bring all these principles together in our school management system and see how they interconnect. 1. Abstraction. We define an abstract class called person, which includes properties like name, age, and methods such as update contact info. This keeps our design focused on essential attributes while hiding implementation details. 2. Encapsulation. The student class can have private properties like grades and attendance records. We can expose these through secure methods like addGrade and getAverageGrade, ensuring data integrity and preventing unauthorized access. 3. Inheritance. We can create a staff class that inherits from person. Both student and teacher inherit from person, enabling code reuse and simplifying modifications. If we need to update a property in person, all subclasses automatically benefit from that change. 4. Polymorphism. We implement a method called GenerateReport in the person class. Each subclass, student and teacher, can provide its specific implementation, allowing tailored report generation for each type. By combining these principles, our school management system is not only well-structured but also modular, making it easier to add new features, maintain code, and adapt to future needs. So why should we care about object-oriented programming in the real world? Let's discuss the key benefits. 1. Scalability. OOP allows you to manage large code bases more efficiently. You can add new classes and objects without disrupting existing functionality, making it easier to grow your application over time. 2. Maintainability. When bugs arise or features need updates, OOP provides a structure that allows developers to fix or enhance specific parts of the code without having to rewrite everything. Encapsulation ensures that changes in one part of the system don't unintentionally affect other parts. 3. Reusability. One of the major advantages of OOP is the ability to reuse existing code. You can create new classes that build on existing ones, which speeds up the development process and reduces redundancy. 4. Organization. OOP promotes a clear structure in your code, making it easier for multiple developers to work on the same project. Each person can focus on specific classes and objects, leading to more organized and manageable codebases. 5. Real-world modeling. OOP is designed to model real-world entities, making it intuitive for developers to translate concepts from their daily lives into code. This makes it easier to visualize and understand the software they're creating. And there you have it, a comprehensive exploration of object-oriented programming, its core principles, and how they can be effectively applied in real-world scenarios. Understanding these concepts is vital for any aspiring developer, as they lay the foundation for writing efficient, maintainable, and scalable code. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the notification bell to stay updated on our latest tutorials. And don't hesitate to drop any questions or suggestions in the comments below. Thank you for watching, and happy coding!